my topic today for you is going to be somewhat in line in terms of machine learning, somewhat in line with the previous talk, but it's about text, so it's a little different. So hopefully there's some diversity here. I'm going to talk about the how we solve the problem of marketing analytics, actually specifically the problem of classifying social media mentions, but there you can apply the same technology methodology to everything else, to a lot of other things, let's say. So our PR asked me to put this slide here. I graduated from Moscow State and did some PhD, and basically the last kind of 18 years about that work in machine learning, now in Toloka, leading ML. So, but really I wanted to share kind of the experience of solving this case. And the case was the case which probably many of you actually have in your tasks is, you have a lot of data points. Well, in this case, we had a lot of social media mentionings. And then the question is, how do you make sense of them if you want to somehow say whether they're all like positive or negative? And our customer, basically, they were processing 2.6 items a day manually. Manually meaning, they used human annotation for this, but they actually collected and wanted to process 60,000 items a day. And that's kind of the case. And of course, the answer is going to be build a machine learning model, but there's going to be more to that than only that answer. All right, and when first a little bit some sort of motivation of why you need to monitor social media. Well, basically, you're a company who tries to grow. Then you want to work on your brand. You want to find topics which are relevant to whatever your company is doing. You want to maybe get some inspiration from some content which was published on the internet, all sorts of different things. And then you're thinking, oh, great, I'm going to solve all these problems with machine learning. And it turns out for many companies, it's hard. It's only 22% of machine learning teams get in prod less than 2 weeks, but actually quite a lot take more than a month and more than even half a year, according to some objective surveys, hopefully objective. And the approach I'm going to share, it works not only for social media classification, but for a lot of other tasks which you might think about, maybe spam detection, sentiment analysis, OCR and speech to text, whatever. There's quite a lot. You can talk to me about them after the talk. Just approximate timeline of like agenda for what I'm going to talk about. And I guess let's start with the actual task. So you have a lot of social media mentions. What do you do with them? Well, the first thing which many people are going to start doing is to classify a lot of, maybe scrape from the internet, classify them into relevant and irrelevant. And then the next step is going to be likely that you're going to classify them into maybe positive or negative sentiment. And you're going to do something with that, right? Maybe if it's a negative sentiment, you're going to figure out, oh, what is this? Is a problem with my software? Or is this just some angry customer because they're forever angry, or there's some other reason for it? And basically, I call these answers to data questions. It's like you have data, you are asked questions, like how do you get answers to them? And the question is how. And so I guess it's time to engage the audience a little bit. What's your opinion? Okay, you have a ton of different social media statements somewhere you scraped over the internet. How do you make this pipeline? How do you classify that? What would be your approach? Anybody wants to answer? And it's not me who is going to answer all the questions today, right? Okay, so the question in the audience is like, what do you actually want to achieve? Well, what you want to achieve is to find something relevant to your company and improve your company given the social media, stream of events. This is what you're trying to achieve. Like, how would you make sense of it? What's the approach you would take? Yeah. Okay, so the suggestions from the audience is to, thank you very much for your suggestion, is to take keywords and then, find something relevant or not. And basically, I guess a person writes some scripts with keywords and try to classify it. That's a reasonable approach. So, I mean, you can imagine that there is somebody, one person who is tasked to do this. Basically, I think, you know, you should process all of this. And it works, but it usually works for fairly small volume because this person starts getting overwhelmed and then you start hiring more people. Turns out hiring more people requires managing those people, and it's also expensive to hire those people, even if they write a lot of keywords. And writing a lot of keywords is maybe not that, you know, actually not that precise. So some people actually go with the option of data labeling services, where you don't hire people on site, you actually outsource this task and say, okay, well, maybe I should hire some people, you know, outsource this task of classifying somewhere else. Yeah, Rob? Yeah, so I'm going to get to that. Maybe, but yeah, you kind of could, but it doesn't answer all the questions. Yeah, so this is part of the answer to your question. The question in the audience was, can you use large transformer models? And the large transformer models is actually many other models before. Things have changed, but they haven't changed as much as to be suitable for every single use case. And the key problem with large transformer models or anything out of the box is that they're not suited for your use case. Like you can have a sentiment which is specifically, you know, maybe specific for your entity or your specific product, or what is relevant to your company is very different than what is relevant to another company. And like picking that model, you got to start working with those models somehow and adapting them to the use case. And of course, you end up very often building your own models, which is quite expensive. And there's lots of machine learning operations and different problems which are going to arrive. So what we actually try to do is to try to help various teams and companies solve this problem by building some sort of a unified framework, which is better than an out-of-the-box model, which is something that adapts to the use case. And then you're telling me, well, you know what, maybe we have one model which is somewhat okay. And then you're talking about this like adaptation, and I haven't actually said specifically about the data drifts, but the previous speaker has. And that's of course something that's going to appear in your system. Is the thing is that data changes over time, and even if you built this model once in Jupyter Notebook and you have these Excel files and someone is processing them, you're going to have some drifts, and then you're going to update your system once a year, and it turns out once a year might not be enough. So there was a very interesting kind of use case relevant one. It's about customer reviews of the scented candles. And so when COVID came, the whole kind of distribution of this changed, right? Like there's a lot of more of, oh, these candles don't have scent reviews. And this actually means different things for your product. I mean, the fact that some candles don't have scent maybe just means the person caught COVID and your product is still pretty good. And mathematically speaking, you have on the left some wonderful situation where your classifier has split the data. And then on the right, it turns out that some part of the space where this classifier has split the data after the drift is now classified incorrectly. And so it happens with concept drift. Then there is also distribution drift, where maybe previously people were writing in, I don't want to say one language, but like here actually on the right of the slide, you can see there's an Old English and New English. I face this kind of every day at work when I hear Zoomers speak, but like basically that's what you get. I mean, you get a different style of language and you get a distribution shift. And if you basically start asking, well, do they really, these data sets, are they really so different? I mean, sentiment, text, it's all kind of the same. Turns out it's not. If you have, if you actually draw using some embedding methods, draw and try to project this collection of texts into a two-dimensional plane, and a projection, and the texts are from different data sets, then turns out data sets are all, you know, lie in different places. So it is a problem, basically. There's some numbers that basically say, I mean, you don't have to read them, but they basically say on the old data it works, and the new it doesn't. And so maybe for those of you who don't really know what data labeling is, or how you can set up data labeling and kind of what's the essence of data labeling. I'm going to share a couple of slides on that. That's data labeling kind of historically is a key product of Toloka, is a key product of Toloka. Toloka is this two-sided platform which connects your tasks, your requests with the Tolokas. And Tolokas are people who execute your tasks. And so somewhere the platform is in the middle. There's a variety of different advantages. First and foremost of Toloka, first and foremost, it has a very wide variety of Tolokas sitting in very many different places in the world and speaking different languages. And so that helps a lot. And then there's a lot of other quality control tools. You can get more details maybe from me later. But what you do in order to do data labeling is you basically go to a data labeling company and say, well, I want this connection and I want this task to be formulated. In order to formulate the task, you set up a project and you write instructions. And you write instructions, you basically say, please annotate these phrases, these paragraphs. This is what it means to be positive sentiment. This is what it means to be negative sentiment, or maybe this is what it means to be relevant to me. This is what it means not to be relevant. And then you, wow, sorry, that is a little distracting. Is the train going just above me? It's not like, but all right. So and so that's basically what data labeling is. I mean, you connect your request with the people who execute, and then your request has to be formulated in a way of instructions, and hopefully people are going to execute it. Now let's go into the machine learning part of this adaptive model thing, which I was talking about. So let's come back to actually to the process, right? To what a lot of different data scientists share on their PowerPoint presentations is what is your usual process of building a model? Well, you first have some sort of data, we call it here a client data stream. Then you explain how to label your data. And basically, what does it mean? This you explain how to label data. You just basically make sense of your task. You realize what your task is, and then you're saying, well, this is my task is the edge cases, and you somehow explain it either in Word to your coworkers or maybe to the people who are going to label it. And then you gather the data, and that's a process called data labeling. And then you prepare data for training by filtering out some bad data, or maybe like actually usually reformatting, which is what many data scientists do nowadays, most of the time. Reformatting data from one format to another, and then you train a model, test the model, and they deploy a model. Basically, bingo, now you're happy. The problem, of course, is that this process actually takes time, especially if you're doing it for the first time. And as I mentioned, there's data drifts through time. And if you don't have infrastructure, and then your model runs in Jupyter Notebook and is never updated, which may or may not be suitable. Very often it's not, because you kind of hope that nothing changes and you don't really track the performance. So what we did was that we took that part, that last part of this process, and said, well, how about we just make it like kind of a box which is adaptable? And so we have this box that, like, we have this hopefully API which is hopefully useful, which allows you to like encompass in one call data labeling, preparation, training, deploying, and monitoring, which hasn't been on the previous slide. And the reason it hasn't been in the previous slide is because previous slides showed the usual process, and the usual process when you just start building ML doesn't include monitoring, turns out. So how does this work? I mean, I'm not going to go into too many technical details. This is probably the main slide, and the main slide like shows two things. One is you have on the top. Oh, wow. Wow. Okay. So you have on the top here. Okay, that's not too intuitive, but you have on the top line, you have a usual process of calling an API, pre-built API for the model. And you have some model hosted somewhere, in Azure, and you have some Kubernetes handling your containers to scale up. And you have an API, external API, you just, ping it. But that's like the top line is like the usual process we have. What we have in addition is that we have this Toloka labeling project set up, and the instructions are set up, so you don't have to do anything to set up the instructions. You don't have to do anything to filter out the performance, because we have it set up. We're filtering the performers according to the quality which is required. And then, so basically parts of the data are constantly being labeled by the human labelers. And the model, as you can see, there's a loop. The model gets retrained regularly and also gets monitored regularly. And as a result, you get real human feedback, regular monitoring, and regular retraining. There's a certain slide of how to use it. I don't think we need to go to the demo, but if you do go to that website, you can try the demo of various models, including some ad generation models. We hope to enable scenarios 2 and we hope to enable scenarios 2 and 3. 2 is already ready for some cases. 3 is going to be ready later. But like basically in scenarios, how to use it? Well, the simplest way to, if you're interested to use it, is to just basically talk to us. And another one is to go to this website and try out the API and see how it works for yourself. So coming back to the case, of course, I mean, it all comes back to, does this help anyone? Because I mean, the technology is cool, the idea, yeah, fancy, but then it turns out it actually helped. I wouldn't share it if it didn't to the company. I was talking about, and now they're processing 60,000 a day, and that's basically way more volume, and the price per label is super small. And the reason is, you know, when you do data labeling with humans, it's usually more expensive than if you host a model online. There's a couple more examples of basically the relevance. Like the 3 steps which I showed in the beginning, if you remember, was a relevance, sentiment, and then classification into the cases of interest, like spam or bug or angry customer. So there's 3 cases here. In one of them, the customer actually had a model which, yeah, that's the case. So in one of them, customer actually had a model which was running, but the model was never updated. And with the updated model, they were able to send to, for human labeling, only half as many labels. And the reason is, when you get a better model, more recent one, it actually is more accurate. And therefore, overall, you get better accuracy and fewer amount of human labels are needed. That's it. We have QR code where you can ask us or you can ask me, and I'm really happy to answer any questions about this. Thank you.
Thank you very much. So first of all, what do you do when the product feedback is positive? What do you do when the product feedback is positive?
When the product
feedback is classified as positive, is there any action you take, or?
Well, so basically, for that specific use case, there was also like, there was a I mean, this is what you first and foremost report this like collection of positive feedbacks to the product, you know, or to management to say, you know, whether to say how satisfied users are with your system. And by the amount, if you process a constant amount of feedback per say week, then you can kind of feel the sentiment of the social media to your specific product. And another thing is you can split this by different parts of your products. Maybe your company has multiple products, and then you still relate them to one or another offering, and then get the track, like measure the traction of every one of the offerings, for example.
I could probably add, because I used to be on the side of one of the requesters, one of the clients of such solution. What they did is actually the loop when the feedback is positive, then the tweet, for example, or the mentioning is sent to some operator who would come back and thank the customer for like being happy or something like that. And of course, like that's the one part. The other part is like collecting some statistics day by day on the tone of sentiments for every product and etc.
Yeah, I'm asking because I've received in the last year a few congratulations email from like a team-wide emails where we just have a copy of the positive feedback and we self-congratulate on this. And otherwise, for the fine-tuning scenario, did you mean of continuing the training from the result of the previous training with the additional data, or restarting the whole training with the additional data?
Okay, so the question is, do we do continual training where we we restart training from scratch, or we train on the, or we start with the previously trained model? And the answer is, so let me give you two answers. One is that there is a, there's two things here. One is, do we start with pre-trained model, or do we start with the randomly initialized model? And in our experiments, it showed that if you start with pre-trained, it most of the times gets better results. But another important topic is, do we only use the new data, or do we use the old data as well? And so that's the whole area of ML right now. Well, at least recently it was popular, called continual learning, where you're trying to keep the model, make the model not forget the old data and only train on the new one. We are just taking all of the data that we have, maybe with some sample, and as a result, it doesn't forget the old data. Or we, and of course, I mean, some of the old data is forcefully forgotten, but we don't do continual learning.
So there was a question about big transformer models in the first. So actually, since you are working with this, I was curious, the model, the modern like GTP3, I think it's called, shows amazing performance. How does it compare to a human Toloka that just gets, you know, the task, and essentially, can we replace them with just GTP3?
Okay, well, so the question is, there are these a lot of cool news, and some people even tried and are amazed by the capabilities of OpenAI's GPT-3 model. Do we really need human labelers here, or there is no need anymore? You know, I'm convinced that you cannot solve your problems with the GPT-3 model as of now, and there's multiple reasons to that. One is, do you host a GPT-3 model? You don't. That's one of the reasons. So the reason is, like, there's actually one model hosted somewhere in OpenAI, and in order to host such a model, you need to take it and learn how to use it, and then actually host it on like multiple GPUs, and that's quite expensive because the GPU machines are expensive. And even if you take some open source models like Bloom, people have reported that they are not nearly as, even though they're larger, they're not nearly as accurate as what OpenAI has, basically. So there's more than data to train the model. There's also a smart way of training it, and there's probably some filter of the data which was done on OpenAI, which was good. So one is that it's hard to tackle these models. Another one is, what are you going to ask this model? If you're just going to ask this model, the question is like, is this positive a sentiment, negative sentiment? Maybe it's going to answer to you, but is the accuracy really going to be as high as if you train a normal, well, I don't know, say normal BERT or even smaller model? Like in our experiments, it shows that when you have like 500, 1,000 data points, the BERTs start outperforming anything which you get out of this huge model, and that's even for a simple task, right? But then as soon as you start thinking about your relevant task, like, is this relevant to my company? Then you need more data than for sentiment.
Maybe my question was not clear. So you will keep your whole pipeline as you described it. We train our own model, we do all that. Which just there is one bit in your pipeline where we take a random person who registered on your platform, show them a piece of text that is description of a problem, and ask them to annotate a given paragraph. So can that be done by GTP3? How does GTP3 compare not to model you train, but to a random person who you hired for a few dollars to do the task?
Well, so if you have a diligent person who is trying to work well with your system, it's like who is actually trying an honest work to do an honest work for your annotation, the person wins still. If you have 3 people, independent people who are trying to do this, they win more, and they're more accurate, drastically more accurate. Now, another important thing with GPT is that you also need to do this prompt tuning. I mean, you need to actually find the right prompt to ask it for. And I mean, the models which are based on instructions are not, at least as far as I know, haven't been released yet, and there was only one paper on this. So I'd say we're not there yet. And there's quite a few months or years to there.
Thanks for the presentation. Could you switch to the slide with the whole architecture, please? So is that something you built for the client exactly like this, and you sell the whole solution to the client?
Yeah. So there's 2 things, right? One is I share this with you because, I mean, if you want your own process, this is our experience, how we built it. Please build yourself, or or like ask us for opinion. Another one is, if you're not interested in building this yourself, this is what we've built inside. And the reason why I think it can be useful to people is because we have engineers who have been building such systems for many years, and so they're like much more reliable. And then there's a whole fault checking pipeline of verifications and also sort of different additional architecture and around it to make it reliable. And
so what I wonder is how extensible it is. For example, the client wants to add another source of feedback. For example, users also give feedback, not only crowd, but users. Do you have ways to feed their feedback to the database, and it just automatically is picked up by the model?
Yeah. So basically, let me ask this. So our current system is so this current system which we built and I'm sharing with you is has built in this specific architecture. There's no additional logical inputs you can put to it. You can, of course, put input into the input data, or basically in the input data you can put something additional, and then there can be some more processing. However, the reason is we kind of just released this, and we are looking for common ways of incorporating additional, say, data points or additional information in a generalizable way. So yeah, let's chat after the talk.